Welcome back. So last week we looked at how our elements can have different masses based on the number of neutrons that they have in their nucleus. Today what we are going to look at is how we can get particles with different charges. Okay, so we're going to be looking at how we can form cations and anions. So how we can form something with a positive charge and how we can form something with a negative charge. And then based on that, we want to analyze the amount of our subatomic particles in different ions. So how many protons, electrons, and neutrons that we have present. We're going to be looking at our balloon and our sputter. We can see initially we have the same number of negative electrons and positive protons in both objects. That means both of these objects are neutral. So when we are neutral, we have the same positive and negative charges, so there's no overall charge. However, when we bring our balloon to our sputter, we can see that our balloon gains electrons. Notice how the protons do not change, but in bringing a balloon to our sputter, our balloon gains electrons. If our balloon gained electrons, now we have more of those negative charges. So our balloon overall is going to have a negative charge. On the other side, looking at our sputter lost electrons. Again, the protons do not change, but our sputter lost electrons. So now we have more protons than we do electrons. So our sputter would have an overall positive charge. So the way we form a charged object is by either gaining or removing electrons. If something gains electrons like our balloon, it has more of those negative particles. So overall, it's going to have a negative charge. If something loses electrons like our sputter, now we have more positive charges. So overall, that object is going to have a positive charge. We can see then when I let go of this balloon, it's going to be attracted to that sputter because our balloon's negative and our sputter's positive, and we know opposite charges attract. What we saw in that simulation. We saw that, remember, number of protons does not change. Okay. However, our electrons can be transferred from one object to another. If something gains electrons, now we have more negative particles. So our object overall is going to have a negative charge. However, if something loses electrons like our sputter, then we're going to see we have more positive particles than negative. So our object overall is going to have a positive charge. Okay. So if we want something to become charged, we either need to add or remove electrons. We are going to call a charged object an ion. Okay, so an ion is going to be an atom that has either lost or gained electrons. Okay. If something gained electrons, we are going to call that an anion. Okay, so an anion is a negatively charged ion. So it's an element that has gained electrons. On the flip side, a cation is going to be positive. So this is going to be an element that has lost electrons. A fun way to remember that is thinking that a cation is positive. Okay, So whenever you see cation, think positive. Let's say we have phosphorus 31 with a charge of -3 electrons. Okay. So we would want to find the number of protons in this phosphorus, the number of neutrons, and the number of electrons. Okay. So protons, these are always going to be the same. Here we just want to look and see what the atomic number is of phosphorus on the periodic table. And we are going to see that phosphorus has an atomic number of 15. Okay, and we just get that straight from the periodic table. Number of protons is equal to that atomic number. Number of neutrons, here we know that our mass number of 31 has to equal our number of protons plus our number of neutrons. So that means if we have 15 protons, we would need 16 neutrons for our total mass to be 31. Okay, so that's more so looking at the stuff we did last week. When we get to the electrons, now we're looking at ions. So here we want to think, if our element was neutral, that means our protons would be equal to our number of. So if we were neutral, this element would have 15. However, when we look at this element, we see this 3 minus. That tells us that this phosphorus has a charge of -3. Our charge is -3. This tells us that we have 3 more electrons than protons, or 3 more electrons than we would have if we were neutral. So if we were neutral, we said that we would have 15 electrons. However, if we have a charge of -3, that means that we have 3 more. So that means in this ion, we have a total of 18 electrons. And then we can see that we have 3 more negative charges than our positive charges, giving us that overall charge of -3. Let's look at one more example here. Let's say in this case, we have beryllium 2 plus with a mass number of 9. All right, so again, we want to find our number of protons, neutrons, and electrons. Okay, so again, to find our number of protons, we just look at our periodic table at our atomic number. If we look at beryllium, our atomic number is going to be 4. So that means we have 4 protons. To find our neutrons, we're going to find the same thing that we did in the previous problem. We know our protons plus our neutrons contributes to our overall mass. So that means our number of protons of 4 plus our number of neutrons has to equal that mass number of 9. So that means this isotope is going to have 5 neutrons. Okay, that leaves us with our electrons. So this is where we're really focusing with our ions. So just like before, if we were neutral, that means our number of protons and our number of electrons would be the same. So if we were neutral, in this example, we would have 4 protons, meaning we would have 4 electrons if we were neutral. However, if we look here, we have a +2 charge. That means that we have 2 less electrons than protons. We have a positive charge, we have more protons than electrons. That means we're going to have 2 less electrons than what we have of protons. So if we have 4 protons, that means we have 2 less electrons, leaving us with a total of 2 electrons in this ion. These types of problems, we really need to look and see whether we have a positive or negative charge on our ion. If we have a negative charge, like in our first example, that means we have more electrons in our atom, which means we had to gain electrons. We have an overall negative charge, we have more negative particles in our ion, which means we had to have gained electrons, so we'll have more electrons than protons. However, if we have a positive charge, like in our second example, that means we have more positive charges, and that means we would have had to have lose electrons. So whatever our charge is, that tells us how many electrons we've lost or how many less electrons than protons that we're going to have. I hope this helps. Please let me know if you guys have any other questions. Have a great day.